Kind of a thing. Synthetic division. This is stuff we went through on Friday, right? Friday. Okay, so synthetic division, right? This is the one where we can take a problem like this, where we're doing division if the bottom is linear, right? So if the bottom looks like x plus a number or x minus a number, then we can do this shortcut called synthetic division. The synthetic division is very simple, right? Remember, synthetic division, it's only numbers. We don't have any variables in this. So what's the number in this case that goes out front?
-2.
-2, good, because it's the, yes, the zero of the denominator, right? The value of x that makes the bottom 0, okay? So that goes out front. What are the numbers that go up here?
5, 11, 3, 6, 8.
Okay, good, the coefficients, right? Okay, so then all we got to do here, remember this little trick. So we're going to bring the 5 down, right?
Yeah.
And then number shows up, what do I do?
Multiply by -2.
Multiply by -2, which gives me -10. Add or subtract?
Subtract.
Add. Opposite of long division, so we add. So we get a 1 times -2 is -2. I add, get a 1. Yes?
Is there anything similar to this we can do it if there's multiple numbers in the denominator, or do we just have to do the long?
Long division. So yeah, that's only shown 10.
Can we do this like fifth grade?
I wouldn't think so.
I did long division.
So, but not a polynomials. Right. So 6 plus -2, 4 times -2. Okay, here's where I want your attention, please.
0.
So I get a 0, right? So I get a 0 in the remainder box. Now, we didn't look at one like that last week, but those are the easiest kind, right? So what that means, if I have a 0 in the remainder box, then that means I have no remainder. All I've got to do, this is my whole answer, it's just the polynomial part of my answer, right? How do I interpret this, though? These are the coefficients of the polynomials. It's easiest to work your way over from the left because you know that the number next to the remainder box is always the constant. That's the coefficient of x, coefficient of x squared, x cubed, and so on. So our answer then just looks like, this is all just equal to 5x cubed plus 1x squared, which is just x squared, right? Plus 1x, which is just x, plus 4. And that's it. Right? We don't need to put a remainder on this one because the remainder is 0, right? So that's the correct answer. Okay, what about one, real quick, one more? So what about this guy? What number goes out front? Okay, I heard it, -3 goes out front.
And then 3.
And my coefficients are 3,
0,
0, good.
-5.
Will it always be negative? Where did the 0 come from?
Because we're missing the x cubed term, right? So you have to have a column for every power, but we're not done.
See how it goes x to the 4th, and there's no x.
There's no x cubed term up there, which means that we have to have a 0 coefficient for x cubed. We have to have a column for every power of x. So this is the column that goes with the x to the 4th, x cubed, x squared, x, but we're still missing one. 0. We don't have a constant, so we need to have another 0 there, right? Okay, and if we work our way through this, we get 3 times -3 is -9, right? We add and we get -9 times -3 is 27, plus -5 is 22. Yeah, question?
So if it was x take away 3, would you have to find just 3?
You're going to be 3. Yep, yep, exactly. So -3 times 22 is -66. So I'm going to get -68, right?
Yeah.
And then -68 times -3 is positive 204.
204.
And if I add those, I get the remainder of 204. So I do get a remainder this time, right?
Yes.
So this time, and remember, that's my constant, coefficient of x, x squared, x cubed. Good. So our answer is going to look like 3x cubed.
-9x squared.
Good.
22x. I cannot see the rest. -68.
Minus
And
68.
you're gonna add x plus 3 plus 204?
No, so I've got 204.
Oh, over.
is the remainder, and the remainder is what remains
Over, after, over.
over the denominator, right? So we end up with,
Why is the remainder so big?
just is. Yep,
66 times 3 is 198, not 204.
68 though.
Oh, 68.
Yeah.
Okay.
Here, tell me about
Okay, so then, so that would be my answer. Okay, make sense? Right? This time I do need to add that extra fraction with the remainder on top. Okay, we good?
Yes.
Okay, go to work. Yes.
If you can't each see
I'm just
division,
kidding,
that
Aaron.
means, long.
Long division, yep.
Aaron, I'm just kidding, that was the difference.